Okay, so we had really the same process for graphing the rational functions. Step 1, find the vertical asymptote. Step 2, find the horizontal asymptote. Step 3, find some extra points. There was some difference between the two forms about how to go about finding the horizontal asymptote, right? If you have A, H, and K, it's just y equals K. If you've got the A, B, C, D version, then it's y equals A over C. Okay, so we can just use those for quick graphing purposes. But essentially, all rational functions can be rewritten in either form. Today, what our notes are focused on is, can you take one where we have these random ABCDs, and can you turn it into what I would call a more transformational form? Because why am I calling it that transformational? Because we've seen A, H, and K before, right? A does vertical stretching or reflecting. H is responsible for moving left and right. K moves us up and down. But we really don't know what A, B, C, D, and that other one are doing. Okay. Now, essentially, or basically, what you're doing today, we're going to see it on the next slide with actual rational functions. But basically, what I'm asking you to do today is if I gave you something as basic as 17 divided by 3. If I wanted you to work that out, what would you do? Well, if you didn't have a calculator.
Oh, I put 3 on the outside and do the little thing.
Yes.
And then find how many times 3 goes into 17.
Excellent. We put 17 inside the quotient or inside the division box. Put 3 on the outside. How many times does 3 go into 17? 5 times. 5 times 3 is 15. What do you do with those? Subtract them. What's left over?
2.
2. We call that a
Remainder.
We've actually kind of reviewed this before because we talked about the division algorithm once. And we also reviewed, remember way back when you first learned long division, you could just put an R2. But then what else did we do besides R2?
Or you have to add a decimal.
Okay, you could add a decimal point, add a 0, and keep dividing. And what else?
Or you could also turn it.
Yeah, turn it into a fraction, which would be a mixed number. So then if this was our result, we would say our answer would be
5 2/3.
5 2/3. Okay. Now we are going to kind of rearrange our answer today because we want it to look like a fraction plus some value k, right? So what we're going to be doing is we're going to take our remainder. In this case, it would be 2. We're going to put it over our divisor, which in today's, with our work with rational functions, this is going to be some kind of polynomial, right? And so we're going to put it over 3. And then we're going to add how many times we got it in whole. So 2/3 plus 5. This is Miss Cronky. Okay. Thanks. Emily, you just got to run to the front office real fast. You'll be right back, they say. But do you agree, here, we'll give you the office pass. I don't want you to get in trouble. They might lock you up if you're out there.
They are ruthless.
Free my dog.
Then you have to miss that.
I know.
I'm going.
But do you agree that 5 2/3 and 2/3 plus 5 are really the same thing?
Yes.
Of course, this is how we write it, so it's a mixed number, but today we're going to have some x's in there. So we're going to write it like this so that it looks like a over x minus h plus k. Okay, so let's see what that looks like. We're going to do the one on the left first. Y equals x minus 7 over x minus 6. Okay, remember, all we're doing is dividing the two things, which happen to be polynomials, and we learned polynomial division last semester. So which one goes inside?
Oh my god.
The one on the top.
X minus 7, and outside is x minus 6.
Wasn't there a little rhyme that they taught us about the going inside?
Oh, I'm not
First
sure.
line goes inside.
Oh, how did it go? First in line goes inside,
Second in line.
Is that boiling?
but couldn't you just switch them around and then be confused? I'm not going to say it out loud
I
so that
forgot
I
how
don't want
to
to
do
confuse
this.
anyone.
No.
Wait, I
Because
wanna
it's
hear
all
that.
line
Because
inside, so they all rhyme.
Because
Say
if
your
you're
side
first,
every
because
line.
if you're
I am
first
so
in line,
excited.
then you get to go inside first.
Oh,
but if
because
you're
you're
second
in a
outside. It's like going to the
line.
club.
Going to the club. Okay, yeah, I can see that. Okay, I get it. Thank you for clarifying. Okay. Now remember with polynomial division, and like this is nice because today they're all going to be of the form ax plus b over cx plus d. That's just linear divided by linear. So it won't be maybe quite as challenging as it was for us back in chapter 4. But remember, you can't worry about all parts of the polynomial. You just really look at the first part. So we're wondering, like, what could we multiply this x by to get x? Or how many times will x go into x? Once. So put 1 on the top. Okay, we can get it in one whole time. Multiply, and that would be like distribution. So we're doing 1 times x and 1 times negative 6. So we get x minus 6. What are you doing with those two things? You are what? Yes, subtracting them. So with both terms, you have to change the signs. This one's going to be a minus x, and this is going to be a plus 6 now. Okay, so change the signs of all parts of the linear factor. And then it should always be that this first term cancels out. If you have an x left over in your remainder for today, you have not chosen the right thing at the top. Okay, so these should cancel out. And then negative 7 plus 6 is negative 1. So we are going to rewrite our function as y equals, what's our fraction going to look like?
1.
Wait, what's my numerator?
1. No.
We usually take the remainder over the divisor, right? So let me go back to the previous slide. We took the 2 and put it over the 3. Okay. So we're going to say negative 1
x minus
over x minus 6 plus 1.
Yay.
There's my A, H, and K.
Totally not confusing. Honestly though, that's not that bad.
It's gonna get worse though.
Yeah,
It's gonna
no,
get
this
worse,
is-
though.
Yeah,
X
if it's
squared.
quadratics or cubics, it's a lot more work. It's a lot worse.
Are those coming?
No, not here.
She's got more examples.
In algebra 3 or pre-calculus, sure. Right now, we'll just stick with linear. Okay, let's do another example. Set it up. 7x plus 4 goes inside. X minus 3 on the outside. Think in your head. How many times will x go into 7x?
7 times.
7 times. Now, 7 doesn't have an x, so I line it up with the constant term. So it's above the plus 4. That way I know I'm done, right? I have nothing else to do. Now, remember, when you have this 7 up here, you're multiplying it by the whole x minus 3. So I have to distribute. I'm going to get 7x minus 21. What am I doing? Minus, plus, subtracting both, so change their signs. And it is possible for you to get some larger numbers as your remainder. In this case, 4 plus 21 is
17. Wait, no. Sorry, I thought it was minus 4. So that's what threw me off.
That's okay. I'm totally fine with it.
minus 4 too. So.
Thanks, Quinn.
You're welcome.
Oh yeah, my plus doesn't look very good, but it makes better for my notes. Okay, so 25. So then we'll say y equals
25
over x
the
minus
fraction is the remainder in the divisor. 25 over x minus 3 plus 7 whole ones. I'm going to talk about that in a little bit. Plus 7 whole ones. Okay. All right. Now, on your homework, you'll be doing this rewriting. So you want to make it look like this. Make sure you do remainder over divisor plus, what will we call that on the top? The quotient? We call that the quotient?
What?
Yeah.
Divisor, dividend, quotient.
Hey.
Yeah. Quotient.
Relax.
Give me a minute.
We got people judging you up here. I'm sorry. Sorry.
Okay, there will be a follow-up question where it says, describe the transformations of your new equation, like you rewrote it in a over x minus h plus k, compared to this equation, f of x equals a over x. Okay. Now, look at these two equations. What's the only things that are different about them? H and k. So if I'm asking you about the transformations from a over x, all you have to say is what h and k are doing. So like for this one, y equals negative 1 over x minus 6 plus 1, we would say it's going right 3, up 1.
Why is it 3?
Was it up?
Oh, 6,
Oh, okay.
because I was looking at the other one. Sorry.
It's okay.
Just testing how empathetic you can be. Right 6 up 1. And what will we say over here?
Right,
3 up 7.
Right 3 up 7.
Oops.
Team effort.
That makes
I heard you broke your phone.
So that's what I think that's what the directions on the homework say. Tomorrow you'll get your quiz review, and there will be some questions that'll be like that on the quiz review, and then there are some other questions where it asks you to compare to the parent graph that we did in our notes yesterday for the inverse, which was just inverse variation, which was just 1 over x. Okay. If I add this blue version up here, now I have to address what's h, what's k, but also what's a doing. So notice the 1 is still the same, but what would I say the negative would do? Would be a reflection. Okay, now you don't have to do that on your homework tonight, but that's coming where it'll say like 1 over x. So that's also a reflection. And then what would a 25 for a be doing? Stretching. A vertical stretch of 25. And you should really only have, I think, vertical stretches is what we'll see. Because otherwise, if it's a fraction, it'd be in the denominator. Okay. Now, yes, I'm going to give you your homework here in just a second. I'm going to look at y equals negative 1. And look ahead. 7.4. Y equals negative 1 over, was it x minus 6?
Yeah.
Plus 1. Okay. So this one is in the form a over x minus h plus k, which we like for transformational reasons. So we can say, oh, just shift it right 6 up 1. That's going to be your vertical and horizontal asymptotes, right? Real easy to see. Now, technically, you can take one of those with a, h, and k and then turn them into ax plus b over cx plus d. But what you would want in order to have like a y equals ax plus b over cx plus d form is instead of having two separate things that are being added together, wouldn't you just want them to be added?
Yes.
Okay. So if I wanted to add these two things, this is a fraction. What is necessary to add fractions?
Common denominator.
Common denominator. So this value over here, 1 over 1, will need a denominator of x minus 6. And then I will give it to the numerator too. So that, would you agree, x minus 6 over x minus 6 is really just 1?
Yes.
Okay, so I'm still adding 1. So this is negative 1 over x minus 6 plus really just x minus 6 over x minus 6. No, if you have common denominators, you just keep your denominator
Oh.
and you add the stuff in the numerators, right?
Yeah.
So negative 1 plus negative 6 is negative 7, and then I'll have an
Whoa.
x, and that was our
God.
beginning problem.
Wow.
Oh, cool.
I know how to do this.
Yeah, so we'll be just adding fractions next week in section 7.4. Getting common denominators with variables in them. And that means we're going to do a lot of factoring. Hip hip hooray! Okay, it's going to be fun. Okay, I will pass out your homework assignment and you will work on it.